Hello students, good morning all of you. I think all of you are safe in your homes. Today in our class I have to explaining to you time of ascent, time of descent and the maximum height, the total time of flight. So these are belongs to our chapter name. It is motion in a straight line. It is one dimensional and these are used to solve some numericals in the NEET level. Of course, it is JEE mains. Okay. In our previous session, we are discussing so many tips for the level of the numericals. So let us follow it. So welcome back to our channel. This is Prasad. You are watching Prasad Physics Tours. So before going to that, you have to subscribe our channel. Let us start our topic today. Let's start our topic. Today we are going to learn some variables in the vertical projected body. So the first variable it is time of ascent. Time of ascent. And the second variable it is time of descent. And third variable maximum height. Maximum height. And the fourth one it is time of flight. Time of flight. Or it may be said to be total time. So these are the variables you have to learn in this video. So these are all must be explained in case of vertically projected body. Vertically projected body. So that is one dimensional motion. One dimensional motion. Okay. Let us write. So here the time of ascent is denoted by the letter TA. T suffix A. So here the time of descent TD. Here the maximum height it is capital H. It is time of flight it is capital T. So let us write. So already you know that in our yesterday we are discussing so many times, that is how the body will be act in case of freely falling and also in case of vertically projected. So let us see. If an object was thrown, this is the object having the mass m, is throwing vertically and it reaches maximum height, it reaches some height. The displacement or distance traveled by the body, that is nothing but s, and the time taken to the body, that is t, and the acceleration in this case, that is a is equal to minus g, and the initial velocity of the ball or the object, that is u. So these are the terms, and the final velocity of the ball it is here v. So these are the terms you have to know in case of vertically projected. At first we have to derive the time of descent, time of ascent. It is nothing but TA. How we can derive that? Let us see. The time of ascent is nothing but the time taken to the body to reach its maximum height. For suppose if a ball is thrown with initial velocity u and it will be reaches after some time, it will be reaches its maximum height. Its maximum height. It means at where the final velocity of the object is equal to the 0, at where the final velocity of the object is 0, that is the time of ascent. Okay, the time taken to the body to reach its maximum height, is called time of ascent. The time taken to the body to reach its maximum height is called the time taken to the body to reach its maximum height is called time of ascent. time of ascent, denoted by TA. So how we can find the time of ascent of a body? So let the time of ascent, it is from the laws of equation of motion, V is equal U plus AT. V is equal U plus AT. So this is the equation you have to watch. We have to choose here. So the equation, it is equal, from this equation, the final velocity of the object, it is equal, V is equal 0 here, and U, it is initial velocity of the object, that is U, and acceleration in case of vertically projected body, that is minus G, and T is equal time taken to the particle or the body, it is time of ascent, TA. So let us substitute these values. It is 0 is equal U plus A nothing but minus G, T nothing but TA. It is equal 0 is equal to U minus GTA, and GTA is equal to U, where TA is equal to U by G. So this is the time of ascent of a body to reach the maximum height. Okay. So the time taken to the body, it is time of ascent is equal U by G. In case of upward direction. Okay. So let us now, we have to derive time of descent. So time of descent is nothing but the time taken to the body, time of descent. That is TD, T suffix D. The time taken to the body to reach, the time taken to the body to reach its ground point from maximum height. This is the important. Is called time of descent. Okay, that is TD. The time taken to the body to reach the ground point from maximum height is called time of descent. So now the ball is coming from its maximum height position. So maximum height, it is equal here. So the ball is come to the ground point and reaches the ground. How much time it will be taken? That is the TD. So this will be in downwards. In first, we have to see, this is the time of ascent, where the time taken to reach the maximum height. Now we have to calculate the time taken to the body to reach the ground point from where? From the maximum height point. Okay, so here in this, the acceleration due to gravity, A is equal, this is downwards, A is equal positive. It is A is equal plus G. Okay, so where you have to V is equal U plus AT. So where it was started? From the initial velocity is equal to 0 at the freely falling. So this is the certain height having the body, and at this position the final velocity, at first the final velocity of the body is equal to 0. This can be used to initial velocity of the body and it will be fall down. And the initial velocity should be increases. At the time of ground point, it has more velocity. So the time will be increases by the increasing of time. So how much velocity it can be attained? Here it is where whatever the velocity we have to project at first. How much velocity we have to project at first? That is U. that velocity is nothing but it is equal to the final velocity of the body in this case. So here this is the initial velocity of the body, and it reaches the ground point. It has getting the velocity v. It is equal to the how much velocity you have to project the ball. That is the initial velocity of the ball, right? So where v is equal to u and u it is equal to 0, okay, and then u it is equal only it is a u initial, okay. So this is the at first we have to project, and a it is equal plus g and t is equal t d. Let us substitute all those values. V is nothing but u. It is equal initial velocity of the ball. It is equal 0 and plus a. It is nothing but plus g. T is nothing but td. So td gtd is equal to u. It is equal td is equal u by g. So this is the time of descent of a body from its maximum height. So let us observe, already we derived that time of ascent it is equal Ta is equal u by g. Ta is equal u by g, and the time of descent Td is equal u by g. So from these two we can say what we are saying, it is the time of ascent of a body is equal to the time of descent of the body. It means the body, how much time taken to reach its maximum height, and that much of time taken to reach the ground point. That is the point you have to observe here. Okay, how much time it will be taken to reach maximum height, that much of time is taken to reach the ground point. So where always Ta is equal Td. Ta is equal Td. Okay. And now we have to derive. So this is equal u by z, and this is equal also u by z, and now we have to derive the maximum height of the body. How we can derive the maximum height? Let us see. The maximum height of the body is equal to maximum height is denoted by the letter capital H. Maximum height, it is nothing but the distance traveled by the body, the distance traveled by the body, the distance traveled by the body to reach the distance traveled by the body until its final velocity is equal to the 0. Till its final velocity equal to 0. It means how much distance the body was traveled till it reaches to 0 velocity. So here, how much velocity it will be taken, how much distance it will be taken to reach the final velocity equal to the 0, that distance it is equal maximum height, that is equal capital H. That is equal capital H here. So this is the ball here. A ball, whenever you have to throw in this way, so this is the final velocity of the ball, and after that I have to given some initial velocity to project the ball in vertical position. So this is the initial velocity I have to given, and it was traveled some distance. When it will be come back at the final velocity of the ball will be equal to 0, then it will be comes down. The final velocity is used as the initial velocity, and it will be comes to the ground point. Okay, so here how much distance traveled by the body till its final velocity equal to the 0. So final velocity equal to 0, final velocity 0 అయ్యేంత వరకు ఎంత దూరం ట్రావెల్ చేస్తుందో ఎంత దూరమైనా కావచ్చు. It is depending on speed which was given to at initial. If you have to given the less initial speed, it will be reaches less distance. If you are given large amount of the speed, initial speed, then it will be reaches more distance. Okay, that is the maximum height, right? So the maximum height is depends upon the, what is that? At which point you have to do, it was depends. It is the initial velocity, initial speed. Okay, right. So let us see how we can derive the equation. So already definition, it is the distance traveled by the body till its final velocity equal to 0. So that is equal maximum height, where the maximum height, the distance, it is equal. How we can derive the distance? Which equation we have to use here? The distance, it is, there are two equations are there. S is equal ut plus half at square, and another. Now let us see which equation is used to here to solve the maximum height of the body. So there are two laws of equation of motion are there for the finding of displacement or distance. That is S equal ut plus half at square, and another one is equal v square minus u square. It is equal to 2as. So here we have to choose. We have to write which factors we have to know. The unknown factors in the equation, we should not use that equation. If there is any unknown factor in that equation, we should not choose that one. If all the terms in the equation are available to solve them, then we have to choose that one. Okay, so let us see. So here in this case, the distance traveled by the body, this is the our aim to find. So S it is equal how much we don't know. Okay, S it is nothing but capital H. So that is equal how much we don't know. We have to find this. In this case, acceleration due to gravity A is equal minus G, because of the body is moving in vertically upward direction, right? And the initial velocity of the ball U is equal to U. So we have to given some initial velocity to reach the, with some initial velocity we have to project the body, and after that we have to the ball will gets the final velocity equal to the 0. Okay, and here we have to find the S value. So let it check these values in these two equations, then clear it is. At first equation there is U value, of course it is U, and there is T value. No, we had no time. We have to don't know the time, because of how much time it will be taken to reach the maximum height. It will not be the point here. But so acceleration due to gravity, A is equal minus G, acceleration is equal A is equal minus G, and T. So here T is the T. We don't have the T value. We don't know the T value. So that's why we don't pick up this equation. Let us check it is. So here V is equal, already V is there, V is equal 0, and where U is equal to U, and A is equal, it is minus G, and S it is equal H. Let us check it out. So let us pick this equation. So then from V square minus U square, it is equal to 2AS. Okay, S it is nothing but capital H, whereas V square is equal 0 square minus U square is equal U square. It is 2 into A is equal to minus G into S is equal capital H, right? It is minus U square is equal to minus 2G H, where capital H it is equal U square by minus gets cancelled, U square by 2G. So capital H it is equal U square by 2G. So this is the maximum height, which is U square by 2G. So this is the maximum height, U square by 2G. So this is the formula to find the maximum height of a projectile body, U square by 2G. So that's why it is only depends on the which value here, initial velocity, which was given by us. So G is always constant. G is equal 9.8 meter per second square for all cases. Okay, but here the variability is initial speed. How much initial speed you have to give it to the ball, that much of distance was traveled, right? So this is the maximum height of a body. And one more you have to see here, that is time of flight. What is the time of flight? The time of flight or total time, it will be said, define that the total time taken to the body, to reach the ground point, the total time taken to the projected body, to reach its ground point. From where? So this is the initial point. We have to project it with initial speed, and it will be reaches its maximum height, and again it will be comes down and reach the ground point. So here there are one time it is time of ascent and another time is time of descent. These two times are addition that we have to get the time of flight, that is the total time. The total time taken to the body to reach its ground point. So that is TA plus TD. You can write that U by G and plus U by G, it is equal to U by G. So where total time it is equal to U by G. Very important. How much time it will be taken to reach the ground point from initial position? So that is 2U by G. So the addition, the sum of it, in other words, sum of time of ascent and time of descent of your body, of a projected body, is called time of flight. So these are the variables here we need to learn. So how we can solve the problems in various cases. In previous NEET questions we have to solve. Here let us see. If a ball is thrown vertically, with U is equal, with initial speed 40 meter per second, then find its velocity in 4 seconds, and find what is that maximum height and time of flight, total time. Okay, so let us see how we can find that. If a ball is thrown vertically with initial speed 40 meter per second, then find the velocity, that is nothing but final velocity in 4 seconds. What is the velocity of the body in the 4 seconds, and find maximum height, total time. So here there is a ball or a body which was thrown vertically with initial speed of 40 meter per second. So here let us find the velocity of your body in time 4 seconds, and also find maximum height of the body and total time to reach ground. Okay, and total time you have to reach ground point. So T is equal to how much, H is equal to how much. Let us find that. So here, what are the factors they have given to us? That is initial velocity 40 meter per second, final velocity you don't know, and time T is equal 4 seconds. Okay, A it is equal, in this case it is upward direction, it is equal minus G, where G value it is equal 10 meter per second square. So then you have to minus g, it is equal to minus 10 meter per second square. Okay. So let us take the equation from laws of equation of motion. V is equal to u plus at. Okay. Where u is equal to 40 and plus a is equal to minus 10 and into t is equal to 4 seconds. It is equal to 40 minus 40, it is equal 0. It is equal 0. Right? Here the final velocity is equal to 0. So already we said that if a body is thrown vertically upwards, the distance traveled by the body until to reach its final velocity equal to 0, that is the maximum height. That is the maximum height. Okay. So the maximum height of a body, it is equal to u square by 2g here. U, it is equal to, already you know that 40 into 40 by 2 into g. G is equal 10 here. 40, it is equal 2 times of is equal 80 meters. How much distance it will moves in upward? That is 80 meters. Okay. With initial speed of 40 meter per second, then it reaches the 80 meters of height, then it will be come back to the ground point. So the total time of the body, it is equal to 2u by g here. It is nothing but 2 into u, it is equal, what is u? 40 meter per second, and g is equal 10 meter per second square. It is equal 8 seconds. How much time it taken to reach the ground point? 8 seconds. Because of the time taken to reach the ground maximum height, it is equal 4 seconds, and again it takes the 4 seconds of time. 4 plus 4, 8 seconds. Okay, I understand. So this is the method you have to calculate in different ways. Okay, and one more you have to see. The displacement of a particle at instant is given by the displacement of a particle at instant of velocity v is equal under root of 3x plus 16. Then find its acceleration and initial speed, initial velocity, acceleration and initial velocity. So here the question it is the displacement x of a particle, the displacement x of a particle at any instant, the velocity is equal under root of 3x plus 16. So here how we can find the acceleration and the initial velocity? Okay, from this equation we have to squaring on both sides. V is equal to under root of 3x plus 16, where v square it is equal 3x plus 16. Okay, v square minus 16 is equal 3x. V square minus 16 is equal 3x. So this is comparing to the laws of equation of motion. V square minus u square, it is equal to 2as, where here u square it is equal 16. Then u is equal how much? 4 meter per second. This is the initial velocity. Right? And from this one, 2a is equal, to compare this, 2a is equal 3. And x is equal displacement and s is equal displacement, where a is equal 3 by 2 and it is equal 1.5 meter per second square. So this is the acceleration of the particle. Okay. So here this is the at any instant the displacement x of a particle at instant time, the velocity is equal, v is equal under root of 3x plus 16. Then find the acceleration and its initial velocity. So this is the process. You have to find the initial speed and the acceleration. Okay. Right, let us see one more. Here there was a question. A bullet moving with a speed of 150 meter per second strikes a tree and penetrates 3.5 centimeter before stopping. What is the magnitude of retardation of a tree and the time taken for it to stop after striking the tree? Okay, so here the question it is, you have to find that magnitude of the retardation of a tree. Magnitude of retardation of a tree. Magnitude of retardation of acceleration of a tree. Acceleration it is nothing but, so already you know that the retardation or deceleration. Retardation or deceleration. Deceleration it is equal to negative acceleration. The acceleration should be decreasing manner. The acceleration should be in decreasing manner. That is the negative acceleration. Okay. So here the initial speed, the bullet with the speed of the 150 meter per second. So initial speed it is the 150 meter per second. And strikes a tree and penetrates 3.5 centimeter before stopping. So stopping it was stopped. The final velocity is equal to 0. Okay. And the distance moved by the bullet, that is S is equal 3.5 centimeter in meter. 3.5 by 100 it is equal 10 power minus 2 meter. So I want to take in equal units, MKS units. Okay, 3.5 into 10 power minus 2 meter. Now let us find the retardation, magnitude of acceleration, retardation of acceleration. It is from equation v square minus u square, it is equal to 2as. Let us find the a value. Here v is equal 0 square and u is equal 150 square. 150 square is equal to 2 into a into s, it is equal to 3.5 into 10 to the power minus 2. Right? So let it be right. A is equal here 150 square minus 150 square, it is equal 22500 by 2 into 3.5, it is equal to 7 into 10 power minus 2. Okay, so this is equal to 3.142 into 10 to the power 5. What is that? Meter per second square. So this is the retardation of the acceleration. So the acceleration, the retardation is equal retardation minus a, it is negative acceleration, is equal to 3.142 into 10 to the power 5 meter per second square. Now let us find the time taken for it to stop after striking the tree. Bullet will be moving in this direction. So this is a tree. This is the tree. If bullet was started moving and hits at this point and striking at this point, it was moves 3.5 centimeter inside the tree, and after 3.5 centimeter distance travel it was stops. So that retardation will be find out by 3.14 into 10 to the power 5 meter per second square. And how much time taken to the bullet to move the 3.5 centimeter? That is the next question. So the time it is equal from v is equal to u plus at. Okay, v minus u. V is equal already it stops, it is equal 0, it is equal u minus at. Why we have to take minus? That is equal retardation. So u is equal to at and t is equal u by a. So what is U here? 150. And what is A here? 3.142 into 10 to the power, what is that? 5. So then the time taken, it is equal 4.6. I think 4.6 into, how much it is? 4.6 into 10 to the power minus 4 second. 4.6 to 10 to the power minus 4 second. So this is the time taken to move the 3.5 centimeter into the tree. Okay. And now coming to the another question. A ball A is dropped from top of a building, and the same time an identical ball B is thrown vertically upwards from the ground. When the balls collision, the speed of A is twice that of speed of the B. Okay? And at what fraction of height of the building did the collision occur? So here two balls are there. First ball, it is the ball A, is dropped from a top of a building. So it is dropping from a top of a building. And at the same time, the another ball, identical ball, is thrown upwards. This is the ball B. So this was thrown in upwards from the ground point. Okay. And from the ground, when the balls collide, speed of A it is at the time of collide, the speed of A it is equal here. The speed of A it is equal twice that of the speed of B. Twice that of speed of B. So at what fraction of height the building did the collision occurs? So at which distance of height, at which height the two balls will be collide to each other. One ball is dropped from certain height in this pattern, another ball is vertically upwards at the same time. At which distance they will be meet to each other, or strikes each other, or collide each other? At what height? Okay. So let us, the first height of the building from the ground point, this is capital H. Let it be capital H. So we don't know how height it has, at which height they can be collide. So we assume that at point C, they collide to each other with certain height, that is small h. At the height of small h, they may be collide to each other. Let it be. Just it is our assumption only. Okay. Now let us find the h value. How much it is, we don't know. Okay. So here the distance traveled by the ball A, it is from this figure, the total distance it is, total height is a capital H, and our assumption height is small h. Then here the height should be, the distance should be h minus h here. Understood? Right. So at first observe, in case of ball A, the acceleration, it is equal plus g, because of it is freely falling. And in this case, the initial velocity of the ball, it is equal 0. And coming to the ball B, in case of ball B, A is equal minus g, because of it is moving in upward vertical direction, right? And in this case, the initial velocity is equal u. Okay, so let us write. So all the terms, and we have to derive it. From laws of equation of motion, S is equal ut plus of a t square. The distance of a ball traveled to meet the ball B, that is S nothing but h minus h is equal ut. U is equal 0. Initial velocity is equal 0 here, whereas 1 by 2 A it is equal plus g t square. This is equation 1 in case of ball A, for ball A. This is ball A. Okay, right. In case of second ball, that is ball B, S it is equal, how much distance it is equal? Small h distance. H is equal ut plus A is equal minus g, then minus g 1 by 2 minus 1 by 2 gt square. 1 by 2 gt square. This is equation 2 in case of ball B. So here what they given to us, that is speed of ball A is twice that of speed of ball B. So this is the, okay. So let us find the speed of the ball. The speed of the ball VA is equal, from laws of equation of motion, V is equal U plus AT. You can find that VA is equal, in case of A, initial velocity is equal to 0 plus A is equal G and GT. V is equal GT. This is equation 3. Okay. And similarly, in case of second ball, VB is equal, we can write that V initial velocity is equal to U and acceleration it is equal minus G into T. This is equation 4. Okay. So from the given data, VA is equal to VB, VA is equal to VB, you can write that VA is equal 2 into VB is equal U minus GT, U minus GT here. It is VA is equal, VA nothing but, what is VA here? GT is equal 2U minus 2GT. So minus GT comes this side, then 3GT is equal to 2U. 2U is equal 3GT. Let it be, keep this. Okay. And now we have to find the height, small h. So from equation 1 and 2, we can divide the equation 1 by 2, second equation. So let us write h minus h by small h. This is the first equation, LHS by LHS, RHS by RHS. It is RHS is equal 1 by 2 GT square and by, what is that, UT minus half GT square. So let us simplify here, h by h, h by h. It is capital H by small h minus small h by small h will be cancelled, it is 1. And here it is equal, you have to GT square by 1 by 2, it is equal to 2 into UT minus, we have to multiply by the 2, it is 2 UT minus 2 into 1 by 2, it is equal, cancelled out, 2 2, it is GT square. Okay, clear? Right. Here h by h it is equal, h by h is equal GT square by 2UT minus of GT square, and here plus 1. This minus 1 should be, comes to plus 1. So let us take the LCM. You can find that. So let us okay. So from this LCM, h by h it is equal, h by h it is equal, what is that, GT square and plus of 2UT and minus of GT square by 2UT minus GT square, 2UT minus GT square. Okay. So minus G plus GT square and minus GT square cancelled out. It is equal to 2UT by 2UT minus of GT square. Already you know 2U is equal to 3GT. 2U is equal to 3GT. Let us write from equation 3, 3GT square by 3GT square, 3GT square minus GT square. Since here 2U is equal 3GT. So 2U, by the replacing of 2U, we have to substitute the value of 3GT. 3GT into T, 3GT square. 3GT into T, 3GT square minus GT square. It is equal 3GT square by, what is the 3GT square minus GT square, 2GT square. GT square, let's cancel out. It is h by h value, where you can get the capital H value, small h value. Let us, h by h is equal 3 by 2, where small h it is equal, we have to vice versa. We have to, it is h by h it is equal 2 by 3. This is ulta. 3 by 2 it is nothing but 2 by 3. Therefore, small h it is equal to 2 into capital H by 3. So this is the height where the two balls are, meet each other, or two balls are strikes each other, or two balls are collide each other, right? So it means, for example, if h it is equal, the height of the building it is equal 15 meters, At the 15 meters height of the building, a ball A is dropped and another ball is thrown same time vertically. At the distance, how much distance they can be collide to each other? That is 2 into 15, 30 by 3, it is 10 meters. At the height of 10 meters, they collide to each other. Right? So this is the process you have to find this one. Right? So let us note. Let us see another question. Let us see one more question. Here it is. There is a man runs across the roof of a tall building and jumps horizontally on the lower roof of an adjacent building. If his speed is 9 meters per second and the horizontal distance between the building is 10 meters. Here it is the 10 meters. Here the speed it is 9 meters per second. And height difference between the roofs it is 9 meters. Will he able to land on the next building? Right? Interesting question. Let us see. So here there are two buildings are there. A man across the roof of tall building. So one building it is tall building here. This is the building which is very height. Okay. He jumps horizontally. Here there is a man. He wants to jumps into the another building. Okay. And jumps horizontally in lower roof of an adjacent building. So here there is a another building. Okay. So this is the ground. So this is second building. So now he wants to jumps into the second building with the speed of 9 meters per second. How much speed he wants to jump? It is 9 meters per second speed. Okay. And the distance between the buildings is 10 meters. Here the distance between these two buildings are 10 meters. So this is the distance between these two buildings. And the height difference between the roof. So this is the roof of the first building and the height difference between these two it is 9 meters. So 9 meters of height. He stayed at the 9 meters of height of first building and he wants to get and jumps into the another building which is at distance of 10 meters. Okay. So our question it is, will he able to land on the next building? So he will able to land on the next building or not? So here our assumption it is, if he travel the distance traveled by the person is greater than to the distance between the two buildings, then he able to land safely on the building. That if he travel the distance between two buildings less than to the distance between two buildings. So if the value it is below the 10, then he fall down. He was not safe. If his distance traveled by a person is greater than to the distance between the building, this is the value should be greater than to the 10 meters, then he safely landed on the second building. Okay. So what we have to find here, the distance traveled by the person here. So if he jumps on the building. Okay. So here what distance it is? Greater than 10 meter. If less than 10 meter, he will be falls down. He will fall down between two buildings. Okay. So let us find the distance traveled by the person. So solution. So distance traveled by the person, distance it is equal, that is nothing but which distance? Let us write how we can find the velocity is equal, the distance traveled by the person it is equal velocity into time of fall, velocity into time. So which time it is? The time taken to fall down, the time taken to jumps. Okay. So distance it is equal, how much distance he located? So that is 9 meter. Yes, it is equal 9 meter here. Already they given to us 9 meter. And the initial velocity it is equal u is equal 0. So he is able to staying at the top of the building. The initial velocity is equal 0. Okay. And the time we need to find. So from laws of equation of motion, s is equal ut plus half at square. S is equal ut plus half at square. So here already velocity is there here. So how much velocity he has? 9 meter per second velocity. Right, s is equal ut plus half ut square. Then s it is equal 9 meters and u is equal 0, 1 by 2. G value is 10 meter per second square. That is equal 10 into t square. It is equal 5. 5t square. 9 it is equal 5t square and t square it is equal 9 by 5. It is equal 9 by 5 it is equal 1 point how much? It is equal 8. 1.8. Okay, so 1.8 second. 1.8 seconds. So then 9 by 5 it is equal, this is of course it is t square, so that is nothing but you have to write that t square it is equal 9 by 5. T square is equal 9 by 5. T is equal here, t is equal root 9 by 5, root 9 by 5 here, it is equal 3 by root 5. 3 by root 5. It is 3 by root 5 value, it is equal 2.36. 2.36. Here it is 1 point, that is 34 second. 1.34 second. 1.34 second. So the time taken to fall on the next building, that is 1.3 second. So already velocity you know that is 9 meter per second. So and then the distance, if the distance is greater than 90, greater than 10 meter, he is safe. He is safe. Okay. It is manaki note point. So whether he is safe or not, let us see. So distance is equal velocity into 9 meter per second into 1.34. So it is nearly 12 meters of distance, that is equal. So just he safely lands on the second building. He safely lands on the second building. Because of the distance between the two buildings is 10 meters, he jumps 12 meters. So then he is safe on the building. Okay? I understand? So this is the problem solving skills you have to learn with the laws of equation of motion. I think you are already, all of you, practicing so much of problems. So one thing you have to remember, if you are skilled in the solving manner, you have to do more practice of numericals. Okay? Doing numericals or making gem in physics. Okay? So wishing you all the best. If you like this video, please hit like and share to your friends.